Linear search is a simple search algorithm. Every item is checked, and if a match is found, then that particular item is returned. Otherwise, the search continues until the end of the data collection. Search algorithm that starts at one end and goes to each element of a list until the desired element is found. How linear search works. Step 1. First, read the search element in the array. Step 2. Set an integer 1 equals 0 and repeat step 3 to 4 till I search the end of the array. Step 3. Match the key with array. Step 4. If the key matches, return the index, otherwise increment I by 1.
Example of linear searching. So let's assume that the key value is 20. The first step, we match the key with the first array index, but the first array index is 0 and the value is 10, and 10 is not equal to 20. So we skip to the second index, and the second index is 50 and it's not 20. So we skip to the third index, and the third index is 30 and 30 is not equal to 20. So we skip to the next one, and the next one is 70 and it's still not equal to 20. So we skip like the same as we do at first, and we know that the fifth index is 80 and 80 is still not equal to 20. So we skip to the next index, and we found that the sixth index is equal to 20. And then when the loop found that the key is equal to the value in the index, so we know that in the sixth index of the array is equal to 20, and the sixth index is 5. Example of linear searching in real life. So let's assume that you need to find the meaning of nice, the word nice in dictionary. So the first letter we have to find is N. So we run to the dictionary. The first is A, no, B, no, C, no, till we found N. And then we have to find the next letter in nice word, that is I. So we ran to find the letter I in the N page, in the N letter page. So we ran NA no, NB no, till NI. So we do this till letter E because it's the last letter in nice word. So when we found the nice word in dictionary, so that's we can find the meaning of nice. So here's the code example for linear searching. As you see in the search method, we receive the array and the key value, and we named it as X. So the first thing we have to do is we collect the array size in the N, and then we loop through the array. So the loop starts from 0 to array size, that is N, and then we check that each array size, which one is equal to X, and X is key. And if we found that value in the I index equal to key, so we return that index through the method that call this method. And if we not found, we return -1. And that's for the code example of linear searching.
We already talked about linear searching. We will continue to bubble sort. Bubble sort is a simple sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. This algorithm is not suitable for large data sets as its average and worst case time complexity is quite high. The real-life implementation of bubble sort depends on the type of data and the amount of data to be sorted. Example of bubble sort implementation include sorting small amounts of data, employee code information in the company, or a list of students in the classroom. Bubble sort is a simple sorting algorithm that works by repeatedly swapping adjacent elements in a list or array that are out of order. It gets its name from the way the smaller elements bubble to the top of the list or array, just like bubble rising to the surface of a liquid. The algorithm works by iterating through the list multiple times, comparing adjacent elements and swapping them. If they are in the wrong order in each iteration, the largest element bubble up to the end of the list or array. The basic steps of bubble sort are compare the first two elements of the list or array. If the first element is greater than the second element, swap them, move to the next pair of adjacent elements, and repeat step 2. Continue the process until the end of the list or array is reached. Repeat the process until no more swaps are needed, indicating that the list or array is now sorted. Bubble sort is not very efficient, especially for large lists or array, and its worst case time complexity is O(n) power. So it is easy to understand and implement and is useful for small or nearly sorted lists or array. A sorting algorithm can be defined as an algorithm or a procedure to put elements of a collection in a specific order. For instance, if you have a numeric collection like an array list of integers, then you might want to arrange the element of array list in ascending or descending order. Similarly, you might want to arrange string of a string collection in alphabetical or lexicographical order. This is where the sorting algorithm in Java come into the picture. Bubble sort is the simplest of all sorting techniques in Java. This technique sorts the collection by repeatedly comparing two adjacent elements and swapping them. If they are not in the desired order, thus at the end of the iteration, the heaviest element gets bubbled up to claim it like full position. If there are an element in list A given by array A index 0 until array index A minus 1 minus n อะไรวะคัดตรงนั้นนี้เดี๋ยวพูดใหม่ if they are an element in list A given by array A index 0 until array A index n minus 1นะIf they are an element in list A given by array A index 0 until array index n minus 1, then array A index 0 is compared to the A array index 1 is compared to array index 2 and so on. After comparing, if the first element is greater than the second, then the two elements are swapped if they are not in order. Advantage of bubble sort algorithm: besides the memory that the array or list occupies, the bubble sort requires very little memory. The bubble sort is made up of only a few lines of code with a base case running time complexity of O blanket n. The bubble sort is helpful in determining whether or not a list is sorted. Other sorting methods frequently cycle through their entire sorting sequence, taking O blanket n2 or O blanket n log n to time to complete. The same is true for data set with only a few items that must be swapped a few times.
The worst case condition for bubble sort occur when elements of the array are arrayed in decreasing order. In the worst case, the complexity of the bubble sort algorithm. In the worst case scenario, the order loop run n time. As a result, the worst case time complexity of the bubble sort is O. Disadvantage of bubble sort algorithm. The main disadvantage is the amount of time it takes. It is highly inefficient of large data set with a running time of O n power 2.
Okay, the last topic we're gonna talk about the bubble chart, and I want you to see the source code here. The first implementation takes an integral array R and short is using the bubble chart algorithm. It first gets the length of array n and the loops over the array n-1 times using two nested loops. The inner loop compares adjacent elements and swap them if they are in the wrong order. After the inner loop, complement in the longest element and get the rest to be at the end of the array. So the next other loop, iterated starts on one element earlier. The steps from the performing double are each following inheritance to the array from the first element to last element. For each attestation element to that array from the first element to last element and shortest element, compare adjacent element and swap them if they are in not wrong order in the same path. Repeat step 1 to T unit. That array shortest. An example use the program is create as array is size 7 and inheritance as element from the specific volume that's called bubble sort. Function to sort the element in the array, it finally print the shortest array